So we got a wonderful panel here. I'm with Mabel, Mike, and Maral. So we're going to be talking about understanding the V1G, V2G, VPP, and all that fun stuff together. So I got a few questions for you guys, right? So my first question would be probably with Maral, is what is the IESO forecasting the demand growth, and how do the EV plan to play a role for this?
Yeah, test. Can everybody hear me?
Maybe closer.
All right.
Yeah.
All right. Thank you, Jean-Philippe. And good morning, everybody. It's great to be here. Thanks for your interest in this panel. And so before diving into that question, I'll just tell you a little bit about the IESO and what we do. My name is Maral Kassabian. I am Senior Manager of the Partnerships team at the IESO. We are the system operator for the province of Ontario. That means we direct the operation of the transmission system, so the high voltage lines. We ensure that supply meets demand every second of every day, 24/7. We administer the electricity markets. We do long-term and short-term demand forecasts so that we understand how much demand we have in the province and ensure we have supply to meet that 20 years out. We also enable conservation and energy efficiency. We consult with stakeholders, and we enable innovation. So with that understanding, let me tell you a little bit about what we're forecasting and how EVs play a role. So our planners do an annual planning outlook, and that looks 20 years out to see what demand in Ontario looks like. So what they forecast is that we're seeing a 60% increase in electricity demand over the next 25 years. 60%. And that is driven primarily by growth in the economic and population growth, as well as electrification of the mining and steel sectors, as well as the EV industry writ large. In addition to that demand growth, we were also seeing changes to electricity consumption patterns, so how people use electricity. And so our forecasters are forecasting that our peak demand, or we're a summer peaking jurisdiction right now, and we are shifting by 2030 to a dual peaking jurisdiction, so peaking in the summer and the winter time. So take those two things together, increasing demand and changes in electricity usage patterns. That's a lot going on, and EVs have a very important role to play in that. And really that role is the flexibility that they can provide to both the distribution network and the bulk electricity system. So understanding how they can reduce their consumption at times of system need, so when they're called upon, how they can reduce their consumption, and perhaps in the future how they can inject back into the distribution network to provide electricity, much like a generator, to the energy system. And so the impact of all of this really is it defers or reduces the need for infrastructure upgrades to distribution utilities and transmission utilities. From the system operator perspective, it helps us to reduce the amount of electricity generation that we need to procure. And if you take this all together, this really equals a cost saving for Ontario ratepayers. And so that is the very important role that EVs play in managing their demand to, at the end of the day, enable cost savings for ratepayers across Ontario.
Perfect. Thank you, Maral. That's a very deep understanding into what the IESO does and what it can do. My next question is pretty much for everybody. So the V2G, V1G, and all that fun stuff, there's a lot of terms being used and thrown around out there, right? Can one of you really explain to me what those terms really mean? Like Mike, Mabel, or Maral, can you tell me like what is V1G, what is V2G, what is V2B, what is V2H? Right? There's a lot of terms being thrown, and I want to make sure everybody really understands what each term really means.
Yeah, I can jump in. So Mike Mulqueen, I work for SWTCH Energy. We're a turnkey EV network operator. So really our core differentiators where we really focus, lean in, is around advanced energy management solutions. Is the volume okay, by the way?
Okay, I think you get a bit closer.
And then supporting a really high uptime network. And that's really important to encourage people to decarbonize their transportation. So they want to be confident that chargers are available for when they need them. It's really great seeing the growth of this event too, I do want to say, year over year. So phenomenal to see the momentum in this industry. So yeah, awesome for showing up. So yeah, V2G, V2X, all these terms that we throw out, vehicle to grid. Really what you're talking about is the ability of a car battery to flow electrons back to another asset. So, predominantly most applications to date have been vehicle to building. A lot is kind of hinging on the capability of vehicles themselves. So V2B, when people say V2G, vehicle to grid, there's very limited actually real world applications of vehicle to grid. So I know IESO has an open call right now for proposals to dig into that issue more. Generally, we're going to talk about both opportunities here. So we might use the terms interchangeably, but we're going to try to be as specific as possible. And when you're talking about regular charger, that's a one-way flow. So like
V1G?
V1G. So you're just talking about electrons flowing from electrical panel through a charger to a vehicle. That's V1G.
Anything to add?
So just to add on to their VPP, virtual power plant. So really that refers to any distributed energy resources that might be grid interactive buildings, electric vehicles, stationary batteries that can be aggregated together to act like a conventional power plant and compete in energy markets.
Perfect. Thank you. We didn't really talk about V2X. What is V2X, right? That's also a term that's being thrown out there.
So V2X is a term that's emerged to refer to vehicle to anything. So because there are so many different applications for bidirectional charging, it could be a direct grid interconnection, it could be to a building, it could be vehicle to load. So for example, when you see cars that allow you to, plug in when you go camping, that's vehicle to load. And V2X is the category that encompasses every application. Just as a one brief clarification, sometimes you will see V2X used in different contexts, in sort of a telemetry or telecoms context. But anything to do with power or bidirectional charging, it means all the different things that the vehicle can connect to.
Perfect. Thank you so much. My next question is also for everybody here. Do you guys have any example of current projects you guys are working on, and any experience in these areas that you guys want to talk about specifically?
Yeah, I mean, we have all sorts of examples of real life vehicle to grid, solar integrated, battery integrated charging applications, tie-ins with energy management systems, distributed energy providers. So one example in Toronto with the developer Tridel and a partner Kite Mobility. They have a shared vehicle that's used for residents in the building. Residents can reserve the vehicle, use it, and then when the vehicle's not being used or when there's not an upcoming reservation, we can pull power from that vehicle to supply back to the building. So it's great application. Vehicle's idle, battery power is not needed, and so that the building can leverage it. We have other, I'll let you speak some of the other projects.
Yeah, so one of the great projects we actually, with SWTCH, we worked on a bi-directional charger and understanding its capability, the capability of the bi-directional charger and bi-directional EV to provide grid services such as frequency regulation and operating reserve. So we were looking at how fast that EV could respond. So frequency regulation on a 4-second basis. And we saw great results. We got some great learnings around the capabilities, what it could do, what it couldn't do. So that was a great project with the team at SWTCH. We also have a number of other projects around managed charging with a number of different distribution utilities and tech companies. And so through that, we're better understanding how customers respond to signals and really how that can be leveraged to support, again, both the distribution network and the bulk electricity system.
Yeah, so I'll start with a bit of background about Peak Power. Peak Power is an energy software company. We enable our customers, who are primarily businesses that have large commercial and industrial facilities, reduce basically energy costs and also meet their GHG reduction goals. And so often what that looks like is installing a stationary battery at their facility behind the meter to participate in various grid programs to reduce utility charges and generate revenue for that business. So this is what led us to exploring the EV space and bidirectional charging, because a vehicle is a battery on wheels. So vehicles can access many of those same revenue streams and programs, and the cost of that battery has already been covered by investing in the vehicle. So if it can be used for that other use case, it helps create a new revenue stream and support electrification plans and help move the needle on that business case. So one of the projects that we've been demonstrating is called Peak Drive, with 20 bidirectional vehicles in 2 downtown Toronto buildings. And those vehicles were actively participating in Ontario's grid, providing basically peak shaving, so discharging to the building during the highest hours of the entire year on the grid, and also participating in demand response. And so those vehicles saved about $8,000 per vehicle per year. So you can see the savings are fairly substantial. We've also been working with SWTCH on a V1G or smart charging project, where basically we're using the same forecasting signals, where we're forecasting when are those peak hours going to occur on the grid, and enabling a software integration so that we can send our forecasting signal to SWTCH chargers, and for the charger to respond to mitigate those high peak costs.
Perfect. Thank you, Mabel. You did answer for a bit of my next question. It was basically what were the revenue stream you can actually generate with V2X or all that fun stuff. But is there any other revenue that could be generated? Does this do any carbon credits? Am I crazy about this one? No, you guys want to talk about it?
I mean, in Canada at least, BC is an exception, but carbon credits generally belong to the network operator, with the exception of fleet providers. So kind of the legislation it kind of avoids a lot of argumentation over, and the reason behind that is they know that the network operator has to reinvest it in more charging infrastructure, and so they've kind of taken a very clear position. Province of British Columbia have their own legislation, and generally the asset owner has right, but they do have to go through the process of registering it. So usually there's a sharing formula with the network operator assisting with the registration. Yeah.
But in terms of revenue generation, I think there's kind of 3 buckets that I think about. One is it's not necessarily revenue, it's rates, electricity rates that are set by the Ontario Energy Board. And so that can be significant savings to your electricity bill if you relieve yourself of rates. So for example, the OEB in 2023 implemented the ultra low overnight, or the ULO rate, and that was intended to incent EV owners to charge overnight when demand is typically low on the system. In addition, actually, just yesterday, the OEB announced their proposal for a new rate for public EV chargers. So looking forward to see that. So that's on the rate side in terms of saving electricity on your bills. But in terms of revenue generation, some of the programmatic approaches, for example, managed charging. If you can reduce your consumption during, after you receive a signal from a utility or a third party, you can typically earn a revenue off of that. And also in the future around V2G, it's not in Ontario yet. I think in BC there's a pilot, and it's being tested in the US. But if you can inject back into the distribution network, you can also earn a revenue off of that in terms of the kilowatt hours that you're selling back into the grid. And this is something that we're really focused on for 2024 Grid Innovation Fund. We're trying to explore programmatic approaches and market participation models of leveraging that flexibility of EVs to understand how that works and how potentially those learnings will lead to enduring solutions that LDCs or distribution utilities can implement in the future, or potentially even the IESO.
Perfect. I have a quick question regarding that. When you say revenue, can we go into positive, or is it flat zero on your electricity bill?
Yeah, so to be clear, these don't exist in Ontario today, these revenue streams.
So it's coming.
I mean, we're hoping to test approaches, and we hope that this type of solution will come. But for something like V2G, if you think about, the perfect example is a school bus fleet, where they can inject back into the distribution network during the summer when they're not, taking kids around, or when they come back from their route and, it's peak demand period and they have some capacity to inject. They could potentially earn a additional revenue stream, not just an offset of your bill, but actually additional revenue streams. But again, this is not existing in Ontario today. We're hoping to explore it through the Grid Innovation Fund and hopefully enable something potentially for the future.
Perfect. Thank you. Very interesting. Yeah. Anything to add, Mike?
Yeah. So, working in Ontario most of my career, now working across North America and kind of seeing how other utilities are grappling with this, taking advantage of the adoption of EVs. Like there are a lot of utilities that are, helping asset owners, drivers monetize this behavior. One example in British Columbia, we have a demand response program with BC Hydro, and it's through a third-party aggregator, AutoGrid. And so AutoGrid receives a signal from BC Hydro, identifying when there's system constraints, peak events. So they send a signal to them. We have an API integration with AutoGrid that allows us to manage the chargers during those times, and then the driver will receive a notification. So if they're plugged in and they're charging, they'll have the option to opt out. So maybe they need a full charge, maybe they're going to drive overnight and they want to make sure their car is full at that point, but the consumer always has the ability to opt out. And when they do participate, they get I think it's a $5 Tim Hortons gift card for each time that they participate. So just one little example of how a lot of utilities are thinking about this. So both for rewarding drivers, for rewarding property owners. One other example, in Toronto, we set up another bi-directional demonstration project where we actually used a blockchain mechanism to provide a financial incentive to encourage people to park there. It generally is targeting leaf owners, but when there's a shared ledger, and so every kilowatt hour that they contribute to that project and it's flowing back into the building, they get paid through that process. So there's various creative ways where you can have either direct grid relationships with distributed energy providers where the money's flowing, or with buildings directly. Perfect.
Thank you, Mike. Mabel, did you want to add to it?
Yeah, I would say certainly, I think this covers the key categories. As Maral said, there are categories of on-bill savings, where the savings are coming from your existing utility charges. There are off-bill savings or revenue, where you're participating in a separate program. And often these different kind of value streams compete against one another. So looking at all the different types of pieces in that value stack and which one is the most valuable at any given time is an important part of the sort of software optimization. These programs vary significantly across regions. They vary significantly based on the load that is behind that meter. So today, currently in most jurisdictions, there is sort of a threshold where once a facility breaks, say, 500 kilowatts or 1 megawatt peak demand, they enter into new utility rate categories, which can be a very unpleasant surprise if it's not expected. But it actually can generate significant savings opportunities, especially if you have a significant EV charging load that either is flexible or that can be paired with a battery so that it can become flexible. And also we're seeing this evolve very rapidly. System operators, regulators, stakeholders on the grid side are really recognizing the significant value that flexible EV charging can provide to the grid. And there's a lot of innovative rate design, demonstration programs, proofs of concept going on at the moment to look at different types of ways that these services can be remunerated so that it creates that business case for the end customer. So today there is absolutely a good business case to do this in many locations, but not all locations. And we're seeing that rapidly evolve as the more and more end users are able to participate in these types of programs.
Perfect. Thank you so much. I have a question regarding what we just talked about, right? Regarding the opt-in, opt-out. Like, as a different example, like I know in Ontario, in Quebec, we have this that you can use your thermostat and opt in on reducing your peak and temperature. And I know we could do the same with EV, right? Like we talked about. But what if you need the EV at a time where they want us to reduce the peak and you need to charge? How do you control this with the opt-out of the option? What's your opinion on this?
Yeah, I think first kind of taking a step back and providing context. So, I think people always think of the worst case, and so it starts with the initial purchasing decision around EV. So, I'm going on a road trip, and what if a charger's not available?
Exactly,
but
yeah,
when
for sure.
you get an EV, you realize most charging happens when the car is parked for long periods of time. So that's at home, that's at work, sometimes when you're shopping. And so, we see in a multifamily building, for example, the average charge is about 2 to 2.5 hours. Car is parked for 10 to 12 hours. So that's what allows you to fit lots of chargers into the building, and you can use load management solutions to make sure when everyone needs their vehicle by the morning, all the cars are fully charged. And so that's making a really smart use of the existing electrical infrastructure, so you don't have to go back to the utility to request more. So I say that just to provide some context, and like that scenario where that driver at that moment needs to make sure their car is fully charged or their battery is fully charged. I don't think it's going to play out that way very often. There certainly will be some instances where critically sensitive that maybe they plug in when their car is just about empty. Most people, they probably have 60 to 70% battery when they plug in for a top up. So that's the kind of I say that to not avoid the question, but just context. And where that situation does arise, there are tools. So, through an app, through notification, very easy to execute that, where a resident has the ability to say, please don't manage my charger now. Ultimately, though, if power is connected to the building gets to drive that decision to a certain extent as well. So both parties have to be part of that conversation, how the opt-out goes, especially when if the building has a financial contract, a contract where they're getting rewarded for participating in a demand response program. There's going to need to be contractual terms on what the building's rights are, the collective right versus the individual right, and I think those are conversations that they haven't been fully developed yet, because I think we haven't had enough real world examples where that's been a pain point.
No, exactly, and sometimes maybe a schedule where you opt in, opt out. Like maybe you opt in during the week, but don't opt in during the weekend, because you're probably out and about a bit more often. You want to have the car fully charged more often than not. Maybe you're sharing the car with your kids. Who knows, right? So yeah, okay, perfect. Did any of you girls wanted to add to it? No? Mabel? Perfect. So I'll go to my next question. Mabel, what are the key differences in what can be done from location or jurisdiction to another? Which jurisdiction are the most forward-thinking, in your opinion?
Mm-hmm. So the I mentioned that there's a lot of different variation in different regions, and this is also changing all the time. There's a lot of jurisdictions that are kind of right at that cusp of exploring what they can do, and also looking to jurisdictions that have really been the trailblazers in this space to see the results of their programs and to see, to replicate what works. So California is a good example of a jurisdiction that really has been at the forefront. PG&E is a good example of a utility that they've launched a V2G program And they launched that program knowing that the chargers and the compatible vehicles, the hardware, was not on the market yet. They got the regulatory approvals, recognizing that there is value for the grid. They created their program, and that program has really driven things forwards because it has helped solve the chicken and egg problem of the hardware manufacturers needing to see that there's a business case and value for their consumers, and the grid needing to see the data to quantify what the value is, how these types of systems perform. And so that program is ongoing. It started with the backup power residential use case, and also has streams for commercial bidirectional charging and residential grid interactive charging. New York is another jurisdiction that's been very active on this front. There's a lot of work ongoing on telemetry, on smart charging, on integrating some of this into their Make Ready programs. And also, New York is a good example of perfect sometimes being or recognizing that perfect sometimes is the enemy of the good, and recognizing that the interoperability and some of these certification standards are not there yet. There's a lot of work ongoing at the moment, but they actually enabled a temporary exception to certain requirements to enable some of these pilot programs to get going and to enable some of this hardware to get out there, to get installed, so that they can start learning while some of this certification and standards process is ongoing. Massachusetts, also another good example, started by allowing, for example, Highland Electric Fleet's V2G school bus pilot project was able to participate in a demand response program through an exception, and that exception has now been rolled out, and there are now more programs, value stacks available for V2G in Massachusetts. And also, we've got Maral right up here on the stage, but Ontario also has been a leader, for example, in the Grid Innovation Fund. So there are business cases today for behind-the-meter distributed energy resources, so that includes smart charging, bidirectional charging, and stationary batteries for large electricity consumers in Ontario. And there's a lot of work ongoing to look at, how do these assets get integrated into the grid, what other programs, and as Maral was saying, exploring some of these other options.
Perfect. Thank you, Mabel. Excellent. Did any of you wanted to add to this? Mike?
Only, so our head of policy, I see him sitting in the front row from SWTCH, Josh Cohen, expert in U.S. utilities and the policy landscape, who's, coming out with new progressive programs and initiatives. So I encourage you to chat with him after, and he can probably add a lot to what Mabel just said.
Perfect. Thank you. My next question is fairly simple, I guess. It's what are some of the challenges and opportunities in having EV support the grid? Do you guys want to add to this question?
Sure, I can start off. So from a system operator perspective, EVs and EV fleets and EV aggregations are not your traditional resource, in the sense that, they have a primary use case, and that use case is for transportation. It's not for providing grid services. And so I think that's both a challenge as well as an opportunity, actually, to work through that. In addition to that, there's several operational challenges. For example, what does aggregated state of charge of, a state of charge of an aggregation of batteries look like? How do we qualify and quantify capacity for an EV aggregation? Who's going to be? How do we ensure that they're there when we call upon them and when they're needed? So those are some of kind of the challenges that we're seeing. The greatest opportunity, I've said this so many times, it's really around collaboration. Collaboration is key in unlocking the value of EVs. So collaboration between the system operator, distribution utilities, the regulator, the Ontario Energy Board, tech companies, OEMs. So across the board, I think really working together is really the only way forward in unlocking the value that EVs can provide to support the electricity system, and really in enabling that smooth energy transition.
Yeah, I love how Maral framed that. So a lot of moving parts, hardware-wise, people-wise, partners. So communication on multiple levels is really the key. So obviously, people collaborating, working together, sharing ideas. But what we see as primarily as a software providers, some of the software integration communication conversations are some of the most important. So the ability to receive a signal from someone like Peak Power, who has market intelligence on what the electricity grid in Ontario is doing, so we know when to react to manage chargers within the building. The ability to communicate with a building management system that has direct either BACnet, Modbus tie-ins at the equipment level, so we know what everything in the building is consuming, and that allows us to put in place logic so we know when to manage charging. The ability to receive signals directly from utility through open ADR communication, again, so we can react directly. And that's just talking about V1G. When you get into V2G, you really have to be mindful of the the end user. So who's using that vehicle. So fleet operations are a great example. One of the projects that we're working on to develop, or I guess to refine fleet management software, is the ability to tie together state of charge, battery size information with fleet logistics. So we know there's a vehicle coming home. It needs a 1 hour turnaround. It's coming back with a 20% battery. We've got a fleet of chargers ranging in size, and so we're able to prioritize which charger that vehicle goes to, as well as prioritize power to that where the vehicle is going to be charging if there's a quick turnaround. Other vehicles, we know, hey, it's done for the night. The battery's empty, but that can park here. This battery's coming back. This vehicle's coming back. Battery's at 80%. Maybe we can use that as an opportunity to contribute power back to the grid or back to the building. So there's all sorts of integration, communication, logistics conversations, and really it fundamentally comes down to communication.
Mm-hmm. Yeah, I absolutely would echo a lot of those points, and that the real key is collaboration between stakeholders in different parts of the industry. We've got a 100-year-old utility sector, we've got a 100-year-old transportation sector, and with electrification, the challenge is we need stakeholders in both of those sectors to be able to come together, figure out what the requirements are, what the opportunities are, and even sometimes just talking the same language. And also making sure the right folks are involved in the conversation. I have an engineering background. I'm sure I'm guilty of this myself, of thinking that this is really just a technical engineering problem. It isn't. It needs the end user in the conversation. It needs consideration of the customer journey, the customer experience. It needs to include fleet managers, people with there's a lot of data out there. There are a lot of service providers out there that have a lot of experience on both sides of that industry, and it's a really exciting time to be in the industry, because there's a great opportunity if we can all work together and pull value from all of those different pieces. And also, I would say just stepping way back to the 10,000 foot level with some really rough napkin maths. Smart managed charging is a necessity. We know that the grid will break if all of our vehicles electrify and plug in with no management at all. Bi-directional charging flips the coin and turns vehicles from a challenge into an opportunity. Providing that flexibility to the grid actually could help the grid decarbonize other end uses by being able to match and level out variable renewable generation, for example. But there's a lot of steps along the way and a lot of different stakeholders, so certainly we see a huge amount of value in innovation programs and demonstration programs that really look at starting to scale up some of these technologies, gaining the experience, and including multiple stakeholders in those projects, so that, for example, Maral gave a great example earlier of a project where the IESO is able to collect the data that they need to understand these systems and the impact on the grid, and to look at how they can be, really scaled out further.
Perfect. Thank you, Mabel. My last question before we go to the audience for see if anybody has questions is, what's next on the horizon? What do each of you see in the future for the V2X and the way EVs and the grid can all play together?
I'll start. I'll start by saying, it used to be a question of if, but it's really a question now of when and how. And so for the how part, I'll reiterate our Grid Innovation Fund 2024 has a dedicated EV stream, which is looking at managed charging, vehicle to building, vehicle to home, both for a reduction in demand and to explore how those EVs can be used as temporary backup power supply, as well as V2G. So we're trying to understand the flexibility of those systems. If you're interested to chat, I'm here, but also my colleague David Mitchell is out here, so he's around for the rest of the day, so please feel free to reach out. He is the expert on EVs at the IESO. Just final point is EVs have a critical role to play for the distribution network and the bulk electricity system. Everybody that's here, you guys all have an important role to play. So looking forward to doing this together with all of you.
Yeah, there's not a lot I can add. I guess I don't think we need anything new. We just need to go faster. We need to improve communication. We need to sort out these protocols and how equipment talks to each other in buildings, etc. I'm preaching to the converted here, but just don't believe the headlines. People are talking about a slowdown because there really isn't. There's so much happening, and especially when you kind of peek your head outside of the local place where you're working. We were down at the SWTCH conference, so all the major utilities converged, and it was in February. And the level of conversation, the case studies, the examples, like real-world examples, these aren't theoretical new technology that needs to be invented. It's things that are actually happening. And so, I walked away from them thinking, yes, everything is here. We just need to go a little faster, and and have some policy-enabling mechanisms and have the right conversations to be able to collaborate on this. But I think we have everything we need. But it's it's a race, and we do need to go fast.
I could not agree with Mike more. That is exactly it. We don't need anything new. We just need to go faster, and we need the right stakeholders involved in the right projects. I think certainly what we see is that V1G or smart charging is feasible now. There's no reason not to roll that out. For any facilities that are exposed to high demand charges. I think what we'll see first is the sort of pairing of stationary batteries with chargers, especially in fleet applications, which supports reducing energy costs based on the way that rate structures are generally in place today. And then we'll start seeing more and more bi-directional charging applications in those specific use cases where it's the best match first. So bi-directional school buses is a good example. Fleets where the schedule is really compatible. So, for example, let's say the fleet is out in the morning and is back in a charging depot by the late afternoon, which is when the grid peaks. And I think once we'll see gradual progression on that side, and once residential, mass market passenger vehicles start to be bi-directional enabled, we'll see a very, very rapid take up there.
Perfect. Thank you so much. Now I want to go to the audience if we have any questions. I think we might have one over there.
Thank you. Yes, I stood up early to compliment the panel. I'm David Katz. I'm the board chair of Ontario Sustainable Energy Association, and I'm here representing over 2,800 subscribers and members, many of them who have solar on their roof, who have the ability to contribute to the smart grid, and we would like to be part of that solution, especially because we're across the province. So I pose it to maybe the IESO or even the technology companies. Those people with solar have canceled contracts. They want to get value from their investment. How can we bring them into the EV charging and the storage and the arbitrage and transactive energy that the US is doing? And I welcome everybody to rejoin OSEA. Thank you.
Thank you. That's a very good question. Who wants to take it first?
Yeah, I can start. Thank you. Thank you for that question. A few things. One is how to get involved. As I just mentioned, Grid Innovation Fund, of course, is one mechanism. But also, there are a number of different initiatives happening at the IESO, and there's a number of different stakeholder engagements that we're holding. So take a look at our stakeholder engagement page and see where you fit and what initiatives that your members might be able to take part of. In terms of expiring contracts, that's something that the IESO is looking at. We have a number of procurements that we have been holding over the past couple of years and continue to. So keep yourself informed with the procurements.
Thank you. I am on the IESO Stakeholder Committee and a former hydro planner. And I think we have an opportunity, especially if we're going to give Honda, $7.5 billion. And so we have to look at EVs and vehicle to create for the opportunities. But I'm telling you, I'm in the U.S. with PNNL, and you mentioned SWTCH. They're doing transactive energy. Can I sell my electricity to the guy next door, as opposed to going through the bureaucracy of, DC to AC to AC to DC to the car? Thank you.
Thank you. I see more questions over there. Let's go 11.
Good morning, Rob Safrata with Novex Courier and West Coast Sightseeing in Vancouver. So we did the first medium heavy duty V2G test in Canada in December with BC Hydro. And I feel in these conferences a little bit like a guy with MacBook at an IBM conference. And this is what you've been alluding to, that things will change in many different ways, be more resilient, and cost less. What I'm advocating for, we're doing 5 years now working with BC Hydro, but the project we're doing with them, 40 of our electric tour buses that they'll use in the winter when we don't, will, for 15 years, will save them $200 million. Because that's a non-wire solution, they don't need to bring transmission lines to a problem substation. So I really believe that the new utilities, the modern utilities, will make contracts. We'll still be getting grants perhaps to buy these things. They're so expensive, but we should also be getting contracts. And what I also would like to say is that today a charger is a cost. You said it, in the future a bi-directional charger is an investment, it's an asset. But I'd like to ask your comments about which utilities, where moving that forward, because avoided cost is billions of dollars for them in a more resilient grid.
Yeah, I could comment on Toronto Hydro, where I worked for a long time. Like, one of the really important enabling pieces that a lot of utilities are looking at, it's that whole transactive element. So like I referenced that small blockchain example that we had, but fundamentally you need a way of keeping track of which way the kilowatt hour is flowing. So Toronto Hydro is developing an energy center, and exactly for that purpose. So all of the distributed assets, they can keep track of which who ultimately owes dollars for that kilowatt hour consumed. So that's a really just small comment on one of those pieces that has to happen as an enabling mechanism.
The other thing I would add is for distribution utilities, how critically loaded are their transformers, right? And that what's the need? And what's driving the need for that managed charging or for that V2G solution? So, I think those are the key decision points in terms of like asset planning. Where I'm not a distribution utility, so this is just what I'm hearing. But following that need and linking back to how fast this is going to happen, that need really drives it all. And I think in Ontario we're working towards it. Some faster than others, some have a more dire need than others, but folks are definitely on it and working on it.
Yeah, and I would also add that I think the avoided costs for utilities, for grid operators at every level of the system are significant. Today, in most places, there is basically there's a wholesale energy market which generally recognizes the value of power or of a resource to the grid as a whole for a large region. Increasingly, we're seeing different jurisdictions enable distribution system operator markets, which basically allow the utility to create a market or to procure for value to their distribution system, and these values can all be stacked together. And once we see it's very dependent on regulations, but utilities recognize this savings, they can calculate these savings, and once the regulatory policies are in place to unlock that, it can unlock a huge amount of capital to support this infrastructure. It is very cost effective. And you mentioned non-wires alternatives. Basically, EVs can provide flexibility, and they can be much more effective than traditional poles and wires solutions to alleviate things at a local level, at kind of a neighborhood level, as well as at that large grid level. So, for example, there are some utilities that are giving bi-directional chargers away for free because the value that they provide is significantly more. I should say, I'm not sure if that's present tense. I think one program has now launched, but we'll start seeing this more and more.
Thank you so much, Mabel. I'm sorry for question 10 and 11. I know there's 2 more questions. I think most of us will stay here after we're pretty much done. We ran out of time, but I really want to thank Mabel, Mike, and Maral for being there and being on this panel with me. It was lots of fun, and I think I hope everybody had all the answers that they wanted, and we covered pretty much everything. Have a good one, and have a good rest of the show. Bye-bye.
Thanks,
Thank
everybody.
you.
Let's
Thanks,
chat more.
Jean-Philippe.